Welcome back, friends. In the previous lectures, we have looked at how to calculate capacity of your bus and transit lines. In this lecture, what we will be looking at is another entity in your any kind of public transportation, that is the station, and how to calculate the station capacity. So, the main concepts that will be covered here are what are the different station types and how they are differently configured. Look at passenger circulation at these stations and what are the station elements and their capacities, right. So, your transit line is as good as your stations, right, because these are primarily the places where people get on and off the your transit lines. So, unless you have enough capacity for people to board or alight from your bus or transit links at these stations, people are not going to use the public transportation lines as much. So, the stations, or what we like to call them as nodes in our entire network, are very crucial, and the design of these stations are very crucial in facilitating a good public transportation system for your city. So, let us look at one by one, give you an understanding of what are the different types of station typologies that are available or you might have encountered in your city or town. So, when you look at the station types, what you will see is you can either call broadly there may be three different categories of stations. One are called stops. So, bus stops may be, they may be on street bus stops, right. They may be just a sign post, a sign mounted on a light post or something like that, and that's also a station, right. I mean, that's where people board get on and off a bus. So, that's one type of station which is an on street station where few or no passenger amenities may be available. There may not be even a bench, there may be some lighting that is available, but there is no cover from rain or anything like that. So, there is no shelter, there is no bench, it is just a basic bus stop. The next one could be a what is called a transit center. These may be off street, right. So, see, the main street may be here and there may be a transit center which is off street, where there are buses that can queue one behind the other and people can get on and off the buses from platforms that have been developed, which are very basic platforms. They may have some passenger amenities, few or many, but usually little bit more than what a bus stop has. So, they may have few passenger amenities, but the other thing to remember is they are off street as opposed to these bus stops which are on the street itself. These are off street. So, hence the number of buses that can be accommodated at this transit centers are a little bit higher. So, these may be termed as transit center. Okay, these may be termed as a transit center. Now, the next category is what is called a transit station. Now, this of course is off street, but it may have many passenger amenities, right. This is a full blown station which either for bus, for light rail, for heavy rail, commuter rail, you may have seen all these different types of stations, and also you may have seen terminals that are either for ferries or for intermodal freight transport. Those may be also called as terminals, and they may also have these station areas. So, usually you will see that the station areas has a building complex. It may have multiple amenities inside them, such as eateries, drinking water, certainly chairs, benches, some may be air conditioned, some may have fans, there may be televisions. So, there are different amenities within that station that allows people to access different bus routes, different railway lines, different metro lines, so on and so forth. So, broadly these are the three different types of stations that you may come across. So, you can visualize that the capacity of Say if you look at the terms of capacity of these different types of stations, the on street station may have the lowest capacity, whereas the transit center may have a little bit higher capacity than on street bus stops, whereas the transit stations may have largest capacity. So, these are capacities in terms of not only the number of passengers each bus can handle, the number of passengers per bus that can be handled at these stations, but they may also be in terms of just purely the number of passengers that this facility can handle as well. So, the number of people that this facility can handle and also the number of people that can get on and off a bus at these facilities. Both those capacities may be varying as you start looking from this to this. The other way around, if you want to look at it, the cost also of building these stations are also very different, right. This may be the easiest and cheapest bus stop to have. You just need a sign, maybe a sign post. This needs a little bit more infrastructure because it's off street. So, maybe you have to do develop a pavement there, develop some loading areas, some passenger amenities. That takes a little bit more cost than this, whereas this may be most costliest to build. So, when you are thinking about which type of station should your city have at different locations, you have to do a lot of calculations, right, benefit cost calculations. So, benefit capacity calculation, maybe cost and capacity calculations, simply because we have learnt these cost and capacity, these two terminologies. So, what are the costs that goes into developing this versus what is the capacity of buses that it can handle. If yours is a small town and your bus route does not require a large capacity, maybe you should have frequent bus stops. You should just design them as bus stops rather than having transit stations, whereas maybe your bus your town does require at least 2 transit centers, right, one at each end of the line, because now there are multiple lines that are operating. So, they may need some time to change from one line to the other line, maybe the bus drivers need some layover time. So, all of that requires at least a transit center, at least 2 transit centers, one on each side of the line. Maybe that is a requirement for your city, whereas the intermediate stops could be all bus stops. So, I am just giving you an example, visualizing how you can pick and choose which type of station or stop or transit center to have in your towns or cities transit line. So, when we talk about station capacity, what we are essentially dealing with is passenger circulation and its level of service. So, essentially what we want to know is how easily passengers can circulate in the station in order to when they are boarding or alighting from the transit line, or when they are waiting to get on the transit line. So, circulation is the parameter on which the station capacity depends upon, passenger circulation. Now, what is passenger circulation? So, here are some questions that you need to know, you need to answer. How many bus bays or loading areas are needed? We already looked at a loading area capacity, right, for buses. Is there enough room for passengers to wait and circulate? Is an answer, is a question for which you have to develop an answer, and based on that answer your station will be designed or stop will be designed. Is there enough space and passenger demand for particular amenities, right? Do people are there a lot of elderly people that access a stop? That if there are elderly people, then maybe you need to put in a bus shelter and benches, even though it may not require the capacity, or the line capacity may not require you to put in a bus stop, put in a seat and a shelter, but the demand of the passengers may want that you put in a bus shelter. So, you have to answer the question of what is the passenger demand for particular amenities, right. Amenities meaning, do they need a water fountain at the bus stop, do they need a shade at the bus stop. So, that is what the amenities mean. Are passenger processing elements, for example, stairs, escalators, fare gates, adequately sized and provided in sufficient manner, right. When you are talking about now a station, a transit station? Are there enough escalators? Should there be escalators or should there be only stairs? Are there enough fare gates? So, when people get in, they have to punch their tickets, right. So, are there enough fare gates for especially while traveling during the peak time, for example, right. Are there enough fare gates? So, you have to answer this question. So, through these questions you can you are able to get an understanding of what are the elements in the station areas and what are their capacities. So, you have to calculate the capacities of these, for example, capacity of stairs, maybe how many people per hour can a stair accommodate, right. How many people per minute can go through a fare gates, can go through those automatic fare gates, right. So, these capacities will in turn affect the passenger circulation in the station area, and the passenger circulation in the station area eventually will affect the level of service and the station area capacity. So, these questions are designed in such a way that they allow you to think, they allow you to think from grounds up and then get to how to calculate the station areas. Which station area elements constrains the capacity, right. Are there any elements which you have to have in the station, but they are obstructing people's circulation, maybe people's flow, maybe, and hence reducing the capacity. So, what are such elements that are obstructing or constraining the capacity, and what are the requirements for emergency evacuation? That is something always you have to keep in mind, especially if you have a terminal or a station or a platform and an elaborate station. You need to have an emergency evacuation plan, because that is the time when the load is maximum number of people are trying to get out of the station area, and for example, your stairs should not be designed in such a manner that they would not be able to handle that capacity. If they are not able to handle that capacity, that is when that is what results in, for example, you may have seen some heard about some incidents where there have been stampedes at stations when people have been trying to get out of a station in emergency times. So, if you have not designed your stairway, for example, that is one element that I am talking about, then that may lead to such disasters during emergency situation. So, you have to keep all of these in mind when you are designing your station capacity. So, the solutions for station capacity and passenger circulation will depend on the principles of pedestrian flow, which we have already covered when we were looking at the pedestrian transport part of this class, right. We have looked at pedestrian flow. You know that flow is the product of pedestrian speed and density is nothing but the inverse of pedestrian space, where pedestrian space is number of the average space per pedestrian. So, we have already gone through all of this in our pedestrian transport segment of the class, and those are the principles that are involved here in determining the station capacity, because again the station capacity depends upon passenger circulation and its level of service, right. So, the output, if you know all these, what you want to essentially know is station element width, for example, stairway width, one of the station elements, that the width of the stairways will determine its capacity, and the capacity of the stairways will determine how passenger circulation is happening, and how passenger circulation is happening will be measured in terms of pedestrian flow, right. So, you get the relationship between all of this. You know the pedestrian flow, if you know the stairway capacity, then if you know the stairway width, that will tell you the station capacity. So, that is how these things are all aligned with each other. Similarly, if you want to know the station element area, also can be then calculated. For example, a platform area, if you know the width, you can calculate the stairway width, then you can calculate the platform width as well, and you can calculate the platform area as well. So, if I were to draw the hierarchy of what are the things you have to know, so you would say that I first will have to know, say for example, the stairway width, that will give you the stairway capacity. The stairway capacity is in terms of passenger flow, is in terms of pedestrian flow, and all of these things together will give you the station capacity, right, will give you the station capacity. So, stairway width, stairway capacity will be in terms of flow, you know the stairway capacity, you will. So, this is one element. So, similarly for stair, then you may have to calculate the capacity of the say elevators. So, you know the capacity of the elevators, you add this capacity to that capacity, or you say which is the maximum capacity or which is the minimum capacity, and that will give you the station capacity. So, conceptually you now understand there are different elements within a station. For each element you have to do a capacity calculation. All of those independent elements capacity calculations will lead you to development of the station capacity calculation, right. But all of this, however, all of this thing is based on the principles of pedestrian flow, because it is essentially the people that are circulating in the station. Okay, so, if you this is a pictorial depiction of a station area, for example, looks like a metro station. So, you get off the bus here, you get on the walkway and you are accessing the station from here. There is lifts, the station is one floor underneath. So, there are lifts here, or there are escalators, for example, the stairs are here, these are elevators or lifts, whatever I was talking about. Here is the platform area is right here, right. There are benches, there are trash cans. So, these trash cans or benches that I was talking about, they are necessary objects that have to be there, but they are impeding the capacity or impeding the flow of that area, right. They are acting as an obstacle, but they have to be there. Trash cans has to be there, benches have to be there, water fountains maybe have to be there, but they are impeding the. So, you have to know those constraints when you are designing for a station area. Maybe since this is an outdoor station area, you need lighting, indoors one also need lighting. So, these are this gives you a holistic picture of what are the different elements in designing a station. Now, let us look at some of the major station elements for which you have to know what is their level of service, or that level of service means what is the capacity of each of those elements. So, for example, the first element may be waiting area. So, this may be a waiting area, and that is the process of sizing passenger waiting area is based on designing of a desirable level of service. So, average space per person tells you the desirable level of service. So, level of service A meaning there is more than 13 square foot per person. So, in this waiting area, if there is more than, for one person there is more than 13 square feet, then you are at a level of service A. So, that is a good capacity or an ideal capacity maybe, whereas if there is less than 2 square feet per person. So, everybody is kind of squished against each other, then that is a poor level of service. So, usually what we usually see is for any kind of scale, people or designers design it at the level of service C to be the middle range of the scale. So, if there is 7 to 10 square feet per person, anywhere between 7 to 10 square feet per person, that is a good good design of a waiting area. Similarly, walkways, now you have to have maybe walkways that connect two terminals in a or two platforms in a terminal, right. So, you have to have certain passageway or walkway. So, that passageway or walkway again depends upon the parameter of pedestrian space, right. You already know how to design, how to measure pedestrian space, measured in terms of number of square foot per person. So, again if you look at C as something that you may want to design it at. So, your walkway should accommodate at least, or should have at least say 20 square foot per person so that they can walk comfortably in that. And now there may be a second element, that is second element that may form maybe a part of the level of service calculation, which may be either speed or flow. So, for example, for a walkway with a space of 15 to 25, people will be walking at 240 feet per minute, or there may be a flow of 10 to 15 passengers per foot per minute. So, again, if you want to design it with two parameters in mind, right. So, think about it as a multiple linear regression equation, for example. So, what you want to have is capacity as y axis as your dependent variable, and your independent two variables may be pedestrian space and pedestrian flow, right. So, there has to be certain amount of pedestrian space, but there has to be certain amount of pedestrian flow as well, right. You may have all the space in the world, but if there are no people walking in there, there is no point having that much space. So, there has to be certain flow as well. So, maybe two parameters you can be used to design the walkway capacity, and that walkway capacity will give you the level of service. So, that is an example of walkways. So, these are again, see, these all values have been developed and these ranges have been developed based on empirical studies that have been done for different walkways around the world, for different walkways in the terminal areas, in the terminal stations around the world. But the main principle you have to know how to do it is by pedestrian flow or pedestrian space, which you already know how to make the calculations, right. The third element and the more very crucial element is stairs and escalators, right. These are are one of the most helpful elements or required elements in any transit station, because most of the transit stations nowadays are either above ground or below ground. Very few are at grade because of the lack of space in urban areas. So, once they are above ground or below ground, you have to have escalators and stairs accompanying them, right. And these become critical elements, especially in terms of evacuation. In times of evacuation, they become very, very critical. So, how to design them, what is the level of service that should be provided in order to run daily activities pretty smoothly. Again, the level of service depends upon space and flow, right. So, in a combined system, you will calculate the level of service of both of them together, but you can also do so separately if you just have a stairway, or if there is usually never a station with only escalators, they are always there with the stairways. There may be some basic older stations that when elevator technology or escalator technology was not there, they maybe have designed with only stairs there. So, that type of capacity can also be calculated with only stairs, but more modern stations have both stairs and escalators. So, the capacity of them can be calculated together as well. Descriptions of each of those levels of service are given here. So, for example, level of service C means speed slightly restricted due to the inability to pass slower moving pedestrians. Reverse flow causes some conflict, right. That is the realistic situation, right. There may be reverse flow, people may be trying to go up, majority of the people may be trying to exit the station. Maybe this is a destination station during a peak hour. So, majority of people will be exiting the station to go to their destination, but there will be still some people who will be trying to access that station, right. So, there will be some reverse flow there possible, and there may be inability to pass slower moving pedestrians. That means, there may be people who are trying to exit, but one person may be trying to exit at a very fast pace, whereas the other person may be trying to exit at a slower pace, but due to high pedestrian volume or high pedestrian flow, the slower person may not be able to cross the quicker person may not be able to pass the slower person. So, that is a realistic situation. That is why I said that level of service C is usually the capacity at which these are designed. Now, say if you want to do it separately, you can have the stairway capacity factor separately, escalator capacity factor separately. Again, all of these are dependent upon. So, when it comes to escalators, it not only depends upon the width, but also the incline speed, and that will tell you how many passengers per hour these things can accommodate. Stairway capacity is dependent upon the width and the flow again. So, you know what the flow is. Sometimes you have at certain stations you have moving walkways nowadays that have typically a speed of 100 feet per minute, which is slower than the walking speed. So, you will see that if you walk alongside a moving escalator, moving walkway, you are actually walking fast. In India, these are usually there at some of the airports, which you can also think as large fancy stations, right. So, they are also terminal stations, if you may, in terms of public transport, if you think in terms of public transport. So, the capacity is limited at its entrance. So, the entrance to the moving walkway, you are suddenly in a walkway which is maybe 100 feet wide, your moving walkway may be only 12 feet wide, right. So, the capacity is constrained at the entrance. Speed not a factor for okay, unless there are people who hesitate when entering, right. You will see that people who are not used to using a moving walkway, they kind of slow down people behind them. So, that's the capacity constraint there. The capacity is similar to escalators, however, it is designed to carry 90 people per minute, which is the same as, or is very similar to escalator capacity. The other ones are doorways. Now, you will definitely have different doorways through which people have to enter and exit a station area. If there are different types of doorways available, what has been observed is that the headway between two people is the parameter that governs the doorway capacity. So, the headways in terms, if it is a free swinging door, so that means you open the door and it swings freely and closes and opens freely. That time the headways between the people are about 1 to 1.5 seconds, and the equivalent volume of pedestrians may be 40 to 60 per minute, whereas if it is a revolving doorway per direction, there may be very low volume of people that it can accommodate, right. A rolling doorway, revolving doorway, and only in one direction, right. So, that is the type of elements that you have to keep in mind while you are designing your station, and each of these, you are seeing each of these elements have different capacities that it can accommodate, right. So, while you want to develop a station area, while you want to develop a station with a certain capacity, you have to know that there are different elements in there that may have different capacities as well. So, when you have to accommodate these elements into the design of the entire station. Similarly, the next element could be the fare control system, right. All of these metro stations have these fare control systems, but you know that during peak hours inevitably you see queuing happening at these stations. Even during non-peak hours you may see queuing happening at these stations. So, what should be how many of these should you have at your station? Automatic fare control is something everybody mulls over. How many of them should you have? Again, the capacity or the volume of vehicle or volume of people that each of these can process depends upon the headway, and the headway in turn depends upon the type of system you have. If it is only a free admission barrier only, then the headways are very small, whereas if you have a double slot coin operated system, a 2 slot coin operated system, then the headways become longer, and the headways become longer, meaning the volume of people per minute, volume of people processed per minute goes down, right. So, that is what that says. Here are some examples from all over the world, what they use and what their headways are. Your exit gates, different size or width of exit gates will also give you different kinds of headways and equivalent pedestrian volume. Similarly, now you see automatic vending machines, ticket machine system, they also have certain capacity, because now people are installing these at a, say for example, this is at a Delhi metro station. Instead of having a person at a booth, they are having many of these automated kiosks. So, they also have a certain capacity. They are at least these are the least standardized ones, because they are pretty they differ, these systems differ from one transit in one city versus another metro in another city, for example. So, two metro systems may have different types of vending machines, and they are not yet standardized. So, their capacities vary a whole lot. Infrequent passengers require more time. If you are not familiar with it, you require usually more time, and if you require more time, then queuing starts to happen, and then it drops, the capacity drops. There is a lot of impact of out of service machines. Suddenly a machine is not working, then the capacity goes down. Some sun glare from outdoor machines. So, there are there are factors that have not yet been standardized, values have not yet been developed for many of these factors, or newer elements in a station design. One of those is this ticket machine system. So, usually if you want to, so here is again just an example of how to develop a capacity of a stairway, right. So, a lot of information is given here regarding the design here. So, there are 4 train cars that are expected to run at a headway of 7 to 8 minutes, 8 trains in one direction. AM peak hour demand is this many passengers, entering this many, value of PM peak entering and exiting and entering as that, with a maximum hourly of this. A maximum scheduled load of car is 200 passengers. So, one car, one passenger or one bogie, if you may think of it, in a metro line can take 200 passengers. Scheduled load, average peak hour factor is 0.7. System operates on a proof of payment basis, thus no fare gates are required. So, there are no fare gates in this system. Sporting events are held at off campus sites and do not impact the peak demand conditions at the station. So, if these are, this is the inputs that are available for your type of for your station, what size of stairway width should you design for this type of a scenario. So, in order to do that, you just start off assuming a certain level of service for which you want to design, and see if you are getting the same width as the standard, as the standards tell you for that type of service, if level of service. If not, then start adjusting your level of service, because remember the level of service has a range. So, if you start off with one end of the range and you do not get the width, then you start shifting to the middle of the range, or maybe the end of the range. Okay. So, you assume a level of service, you determine the design volume, and determine the sizing. So, say a level of service C is reasonable to assume, loads of one train 15 peak, 15 minute peak. So, you always design for the peak hour, right, and we have looked at this in the previous in other calculations also, calculations of level of service of pedestrians and bicycles that we have looked at. Always calculate it for the peak hours, because in the peak hour your system has to hold up to the volume or the flow of people coming there. If it holds up to that maximum volume or flow, then it will be able to easily hold off on lower volumes and lower flows during the non-peak hours. So, you always have to design for the peak hour, and but with considerations for the emergency situation also, which is even higher than the peak hour, right. So, always keep that in mind, and if you design that keeping that 15-minute peak in mind, then you will have to be you will be safe. And passengers waiting on a platform to board during the 15-minute period, assuming that the trains are running one headway late. Always assume that to be on the safe side, always assume that the trains are running late by one headway, so that there are actually passengers that are waiting on the platform. If all the passengers get on the train and there is nobody left, that means it's the trains are running on proper headways and everybody is getting on the train. There is no excess volume, no excess capacity. But in order to develop the stairway width capacity, always be on the safer side, conservative side, and think that there is one headway delay in the running of the trains. So, you know how to develop the peak hour volume. If you are given peak hour flows, you just divide it by 4 times peak hour factor. Peak hour factor was given as 0.714. So, you now know that in peak hour 15 in the peak 15 minute, there will be 1120 passengers trying to access your stairway. So, if you assume that your stairway pedestrian flow is again at the level of service C, so which means 7 to 8 passengers per feet per minute, then your stairway width has to be, in order to accommodate 1120, your stairway width has to be 90 inches at least. So, you are 90 inches wide, 7.5 feet wide stairways you will need. Then you can divide it up into how many inches you need for people going up versus going down. You may put a railing in between the width in order to segregate those two flows. You give an additional buffer of 30 inches maybe. So, these are all calculations that differ from station to station based on actual observations, but as long as you get an understanding of what your stairway width needs to be, then you can make those adjustments based on your individual calculations at your individual stations, right. Similarly, if you want to determine the stairway width in case escalators are already provided, then you will see that if escalators are provided, then the calculations are very similar, but what happens is you do not have to have so much flow, such a high flow of passengers using the stairway, because if there are escalators, people are more inclined to using the escalators than the stairways. So, your stairway width can go down a little bit. So, for example, now if there were escalators provided, then your stairway width can now be only 4.4 feet, whereas if there is no escalator provided, then it has to be 7.5 feet, right. The only thing that changes here, again see, this is 10 feet per, we have assumed level of service C, that is 7 to 10 passengers per feet per minute, whereas here we assume a level of service E, which is 17 passengers per feet per minute, because that much load it will not take, the load will be shifted to the escalators. So, there you go, there you get an understanding of how to develop the capacity or how to develop the width of a stairway, assuming a certain capacity or a level of service. So, that again brings us to the end of this lecture. Again, it is the same reference that was provided to you in the previous lectures as well. All of these solved examples are available there. So, please download, this is available for free download, and you will be able to follow through when you read through this reference. So, in conclusion, we showed you today about the different station types, the various design elements of the station, how much station elements impact station capacity. Remember, there are different elements within the station that will impact. So, you have to understand how different capacities of these different elements are, and we gave you an example of how to measure the capacity of one of such element, which is the staircase. Thank you very much for your attention.